For the displays, I'm going to try these classic LED displays. These are rather interesting. They consist of individual LED, and they're kind of visible because you can see right through the plastic or the potting in the front. Each segment consists of 2 LEDs, and we're going to try these. They have a rather classic or antique display look. Of course, wiring this display module is going to be rather interesting. And I have a couple of them on the breadboard here. Let's see if we can get this in the camera. I don't know. Well, I finally got the LED matrix, display matrix wired, the back of the connectors anyway, dip socket between the 2 digits in the clock. And this is quite a exercise in patience getting this wired up. In this phase of the development, I've got the UNO talking to a 74HC595 serial in parallel out shift register, and just doing some tests here, running back and forth wig-wag on some LEDs. And I know I'm going to need some higher drive current for the actual displays, so I have a ULN 2083 Darlington driver driving the LEDs, so that for the actual segments. I've got the small, or the LED display board tacked onto the prototype or the breadboard here, and the next step will be to get the output of the 595 shift register talking to the displays on the breadboard. At this point, I've got pretty much all of the hardware assembled. Rather unusual. There's a resistor ladder line here running off 5 volts, and each time you push one of these buttons, it applies a different DC value to the analog input on the micro. And just by looking at different analog input values, you can determine which switch is which switch was pushed. And we have the 4-digit display. Each digit of the display is driven by a transistor here. Even though there's only 4 digits, the 5th transistor drives the LED array here, which ultimately will be the status outputs. And of course, here's our UNO board for prototyping and for testing. And we come around this side, and there's the HC595 shift register and a ULN 2803 driver for driving the LEDs and the displays. And also up in the corner here is the DS3231 clock module. If I can get a close look at that. Yeah, I suppose we can. Little clock module. It has a small battery for backup. Supposedly 5 years, but we'll see. Don't know how long it was sitting on the shelf at the vendor's shelf before I got it. Again, there's the LED status array. 3 push buttons for input. Before using the small opto-isolators, which are relatively small, they're 120 volt, 8 amp maximum. I decided to put them on a breadboard just to test it out. What I did here is a small 28 volt transformer in series with a 28 volt lamp, and I'm able to turn the opto on with, as per the spec sheet, about 1.2 volts on the LED emitter side, and it does switch on and off quite well at 10 milliamps. So that's encouraging. We've got 2 inputs, diode isolated, one for a bypass switch and one for the logic input. And I still have to test the 2 4 and 33 optos here But this is just testing the high voltage 110 volt switch, which again switches reliably at about 11 milliamps of LED input current. And the output board basically consists of a large 110 volt optical isolator, which is controlled mainly by timer number 1. The two little 4N33 opto isolators on the left hand side here are just general purpose outputs for timer 2 and 3, and they aren't really committed to anything except for just general purpose timed outputs. Well, the next step of course is now to configure the front panel, and I'm just laying out the components that'll be on the front panel on the mini box, and we're going to make a small and try to get all of these parts situated on the front panel so they all line up and they look halfway decent. Now I'm checking all the LEDs that'll be used on the front panel. At 5 volts, I just have them all in parallel, make sure they're all okay. And these yellow and green LEDs are very efficient. The red one's not quite as efficient, but that doesn't really matter. And just to make sure that they're all roughly the same brilliance at 5 volts and with the same current limiting resistors. And they are. So these look like they'll work pretty good for the front panel LEDs. The complete prototype has been completed, which is nothing more than, well, an Arduino with the front panel LED display is on the lower left, the opto isolator output board is on the upper left, a few transistor drivers in the middle. On the right is the shift register and UNO2803 LED driver, or Darlington driver, and of course in the front you have the 3 push button switches. Let's see if we can zoom in a little bit here. There's the 3 push button switches. Front panel LEDs, of course the driver board LED, or the opto driver output driver board, is on the left. Transistor drivers in the middle here, and of course the shift register and ULN2803 LED drivers. And last but not least, our lonely little Arduino in the background there with a USB connection. Well, this will probably be the last video I take of the completed prototype. Everything is working. All the software is pretty much done. The processor and I/O board are completed. Now it's time to take it all apart and build it into the proposed metal housing. And after all the work I put into this guy, it's going to be kind of a shame to tear it all apart. So we'll get a few shots of hopefully a few details here of the prototype just before I have to take it all apart and reuse the components for the final assembly. And again, quite a shame that I have to take this all apart, because I did put a lot of work into this. But it was fun, and it's an easy prototyping scheme for getting something to work before you put it all together and do a final assembly. So we'll see how this works out. Well, I've got all the parts put together in one spot to do the construction of the processor board, build this, and it's almost like a clone of a Arduino Mini or Micro or whatever the smallest Arduino is, with the one 328 processor, a crystal, and a time clock module. And that's pretty much all that's going to be on this board. And again, could have been easily replaced and A lot of labor here for something I could have done for about a $5 board, but oh well. I had the parts, so we'll just finish it and see how it works out. Well, with a couple of evenings of wiring and plugging and so forth, I finally got the processor board completed. Here's the USB to TTL converter for programming. It's not part of the processor board. That'll be removed after, the final timer software is installed, but the little umbilical cord will stay there for additional programming if need be. And I put just a little simple Arduino blinker to test to make sure it's running, and it is. And did another software test, and am able to read the clock module without any problem, and another timer for the beeper, and that works fine. So it seems to work. And again, this is just nothing nothing more than a copy of like an Arduino Mini or Micro or whatever the smallest Arduino is, with a few differences, of course, the beeper and the time clock and so forth. But the blinker works. And pretty straightforward, just a bunch of point-to-point wiring on a proto board. So it's pretty straightforward. So this is the heart of the timer project. And the next board, which is going to be a little bit more complicated, will be the I/O board, which has several transistors and drivers and so forth. And I was also able to, in that same time frame, finish up the CAD plot. But again, I'll never do this again. This is crazy. I'll just since I had the parts, I do it. But if I ever had to do something like this again, I just use a full Arduino board. I wouldn't try, prototyping and hand wiring everything with a discrete processor. This was way out of line and way too much work for what it's really doing. The last few evenings, I've pretty much completed the display driver board. And what this basically consists of is there's a 595 shift register, serial in, parallel out shift register, and a ULN 2803 Darlington driver. And on the left side are the processor board inputs, and over on the right hand side that are the LED or display outputs. And we have on the outputs, we have 5 columns, or actually 4 digits and 1 LED column. So these are the common anode driver transistors here for 4 digits and display LEDs. And here are the current or the resistor limiters for each individual segment of each display. And of course it's multiplexed throughout. And of course there's a lot of hand point-to-point wiring, which gets a little tedious, but it doesn't take too long. It moves along pretty quickly. I suppose a printed circuit board or something would be nice, but being on a one-off project, it's close enough. A little tedious, but it works. Well, I've stripped all the major components off the prototyping board, plywood board, and now it's time to start constructing it into the metal housing. And that's probably going to be the biggest construction project, is doing the metal work. But we have all the major sub-assemblies ready to go. They've all been prototyped, tested out. Software has been tested. Now it's just putting it all together and wiring it back up. Well, I've got most of the holes drilled in the chassis. Did that over the last day or so. And of course all the sub-assemblies now have to be installed in the chassis. And the mechanical part of the chassis should be done at this point. Now it's just a matter of assembling and wiring. We've got about halfway through wiring up the main boards in the timer. And that's a lot of the construction work right there, is getting The board, the interconnections to the boards wired up. And of course getting the AC wiring completed. Have to be a little careful with that, but it's not too much of a challenge. Through the 5-volt power supply block and through the AC opto-isolator. Well, our timer clock is virtually complete now. I still have to update a lot of the CAD drawings and so forth, but it's running pretty good right now. All the digits, I've got a little test software running right now. Basically it just turns on all the segments and all the front panel LEDs, and of course it's scanning right now. It's not static, it's scanning. That's why you're probably seeing a little flicker in the LEDs, but it's running pretty well now. I had some wiring errors to begin with. Those I sorted out. The mods have been done on the, or hand mods have been done on the drawings, and I have to update those yet. But we should be in pretty good shape now. And I really love those old retro LED displays. I think those are really cool, where you can see the little dot matrix segments.